Welcome again, my math minions. It is Fraser Nation. We are here once again doing this flipped classroom. And today we're going to talk about 2.7, prove angle pair relationships. Proving angle pair relationships, we know everything in this section. We just need to be able to use some of the important stuff to use in proofs. The objective for today is students will be able to use properties of special pairs of angles, linear pairs, supplementary angles, complementary angles, vertical angles, those type of angles. We're going to be able to use the properties of those. The essential question I need you to be able to answer is, what is the relationship between vertical angles, between two angles that are supplementary to the same angle, between two angles that are complementary to the same angle? What's the relationship between all three of those? The most important things to remember are right angles are 90 degrees. You know that. Supplementary means two angles are 180 degrees, add up to 180 degrees. Eventually, when you have a supplementary pair of angles, that's going to make a straight line. Complementary means two angles are 90 degrees. Linear pairs are two angles that make one straight line. So supplementary and linear pair, those are related. Okay? And vertical angles are two angles that make two straight lines and they share a vertex. Hence the name vertical angles. Okay? Next card. Basically in this section, we don't need the vocab because we've used the vocab several times before. So you don't need it. We're going to have a few theorems, one of which is the right angle congruence theorem, which is all right angles are congruent. So I need you to have the pictures, and you can say here that angle 1 is congruent to angle 2, which is congruent to angle 3. Okay? These three angles right there. So a right angle in Europe is the same as the right angle in China, which is the same as the right angle in Istanbul, which is the same as the right angle in Fraser Nation's classroom. All right angles are congruent, okay? I know that might seem obvious, but remember, this is a theorem, okay? So all you would need to do, put your statements, put your reasons, you'd be able to prove this theorem. Next card, the congruent supplements theorem. It's a little twisty, but it's really kind of the same. It's simple to me. So two angles are supplementary to the same angle, okay? So 2 is supplementary with 3. 2 is supplemental with 1. 3 is supplemental with 1. Then the theorem says that 2 and 3 have to be the same, okay? So right here, if 1 and 2 are supplementary, 1 and 3 are supplementary, then 2 and 3 have to be the same angle. And let's look at this. So if angle 1 is 56 degrees, okay, and we know that 1 and 2 are supplementary, then we need to do 180 minus 56, which is equal to 124 degrees, okay? So angle 2 is going to be 124 degrees. So now I know that these are supplementary, okay? However, if 1 and 3 are also supplementary, then that means that angle 2 and angle 3 have to be the same measure. So that means angle 3 is going to be 124 degrees, okay? So again, if 1 and 2 are supplementary, 1 and 3 are supplementary, that means 2 and 3 are the same angle. The congruent complements theorem is the same exact thing. If two angles are complementary to the same angle, then they're congruent. So if we know that angle 5 and angle 6 are complementary, and we know angle 5 and angle 6 are complementary, then that means that angle 4 and angle 6 have to be congruent. So if angle 5 is 76 degrees, and we know that they're complementary, and remember, complementary is 90 degrees, then 90 minus 76 is equal to 14, okay? So angle 4 is 14 degrees. Well, 6 and 5 are also complementary, so that means that 4 and 6 are going to be the same measure. So angle 6 also has to be 14 degrees. Okay? Theorem 2.6, the vertical angles congruence theorem. All vertical angles are congruent. So remember I told you, vertical angles are two angles that make two straight lines. So angle 1 and angle 3 are congruent, angle 4 and angle 2 are congruent, okay? You need this, we use this for the rest of the year. This is something that you really need to have memorized. And finally, postulate 12. So in 2.4, or section 2.4, so let's say section 2.4, we had postulates 5 through 11. Okay, numbers 5 through 11. Okay, so we have postulate 12 here. And this is something that we cannot prove. Remember, postulate, we can't prove that. Okay, so if two angles form a linear pair, so I have two angles, 1 and 2. If this is a linear pair, okay, then they're going to be supplementary. Okay, now it should follow that if 1 and 2 are a linear pair, then the measure of angle 1 plus the measure of angle 2 is equal to not 18 degrees. It is going to be 180 degrees. Okay? So if linear pair, then supplementary. If supplementary, then 180 degrees. Got it, practice. Okay. It's a little bit different from the book. Use the diagram. So make sure you get this diagram in your notebook. If the measure of angle 1 is 112, so remember I told you in geometry, if it's not in the picture, put it in your picture, okay? And we know that we have a linear pair right here, okay? So for angle 2, since this is a linear pair, and let's write this down, straight line, straight angle, is equal to 180 degrees, okay? So that means that angle 2 is 180 minus 112, okay? So 180 minus 112, and that's going to be 68 degrees, okay? So measure of angle 2, 68 degrees, okay? Vertical angles theorem, 1 and 3 have to be the same angle, so I automatically know, because of that theorem, that angle 3 is 112 degrees. And then vertical angles theorem again, 2 and 4. So 2 and 4, 4 has to be 68 degrees. Okay? Okay. So if measure of angle 2 is 67 degrees, then vertical angles theorem says 67 degrees. We could do 180 minus 67, which is going to be equal to 113 degrees. So the measure of angle 1 would be 113 degrees. And then vertical angles theorem, angle 3 has to be 113 degrees. And I didn't write this in, but that's 67 degrees. Okay? And then number 3, same thing. Okay? Same thing. If measure of angle 4 is 71 degrees, we automatically know that number 2, angle 2 is 71 degrees. 180 minus 71. So this is equal to what, 99? No, it's 109. Y'all fault. Okay. So angle 1, 109 degrees. And then angle 3 is 109 degrees because of the vertical angles theorem. Okay. So it should be obvious that when you have vertical angles and you have straight angles, you're worried about supplementary angles and you're worried about vertical angles. Which previously proven theorem is used in example 3 as a reason? You don't need that, okay? You don't need that because I don't have example 3. Okay, so you do not need this. Do not put that in. Okay. Angle 5. So angle 5. Got it, practice number 5. Solve for x. So first and foremost, we know that 32 and 3x plus 1 degrees is supplementary. We know that since straight line is equal to 180, we know that 32 degrees plus 3x plus 1 equals 180 degrees. Okay? Combine like terms, so this is 3x, combine like terms, plus 33 equals 180 degrees. Subtract 33 on both sides. So I have 3x equals 147. Okay? And then x is going to be equal to, what's this? Her brain farts. 49 degrees. Okay? So x is 49. Okay? And we know TPS. Okay? So to find TPS, we need to know what this is. So first, plug in. Okay? Plug in x. Okay? So I have 3 times 49 plus 1. Okay? So that's going to be 147 plus 1. So that's 148 degrees. Okay? And the reason I wanted to do that is because vertical angle theorem says if this is 148, then measure TPS is 148 degrees. Okay? So the answer right here is 148 degrees. The answer here is 49. We out here doing it like we do big. And hopefully you're ready for your Unit 2 test. Yay. Okay. Look for Quizlet. Okay. I'm going to try to get that on out and deployed. Look for a review/study guide. Okay. I feel like that's going to help you out big. And then, hey, Unit 2 comes quite soon. All right. See